we've been sprinkling in data acquisition, disk duplication. You've been hearing about it throughout the course in little pieces here and there. So what we need to do is we need to bring this all together and say, what's the process look like? How do we deal with it? What are the problems? What are the small components inside of there so that we can actually get this done? Now, if you forget everything else that we talk about here today, there are two ways to do data acquisition. One is using DD, disk duplication, started way back in Unix. And two, the tool that your senior examiner tells you to use, FTK, Smart, or EnCase. So if you forget everything else, remember that. But let's dig a little deeper. Let's be forensic scientists. So we're going to talk about acquisition. Formats and methods is a pretty big deal. DD is one of those formatting methods. What's the best acquisition method? There isn't one, I'll tell you that right now. And then we'll deal with the contingencies, static and live data, volatile data collection methodologies, types of volatile information that we're interested in. And this gets more into the theory side of it, because when we did the Windows forensics, what we said was, okay, here's how you get this registry key, here's how you get this volatile information. Now what we're saying is, here's the types of it, and how can you use them and apply them and make them work for you to support your case. And then we'll talk a little disk imaging tool. I'm going to show you one of the hardware disk imaging tools, along with data validation, which really what we're saying is hashing there. How to deal with RAID disks because they cause some problems. A little best practices, software and hardware tools. And one thing I want to say to you that's really important is at the end I have about 10 slides on questions that you should ask and be prepared to have a vendor answer when you're choosing disk duplication and data acquisition tools. Because you can spend a lot of money on these tools. You need to say, I want this feature, I need this feature, I don't have to have this feature, but I do have to have these features based on the requirements of your lab, based upon your forensics practice, based upon the litigation process that you may or may not be going through. You need to answer all these questions. You need to look for them. And I found a really great site that helps us with that, and I used their questions because they want to sell us hardware disk duplication tools. They want to be the leader in the market. Okay. What we're doing in data acquisition is we're saying, this computer has evidence on it. Let's get it off. Then once we get it, we want to control it, review it, and deliver it to the court. And data duplication is the act of making a copy of the data. I mean, that's really what it comes down to. We have to add in a forensic manner because that's what we do it for. Now, there are three main acquisition formats. The raw, which is what we do in the DD. Proprietary, a particular tool. By the way, that tool is EnCase, and that format is specific to them. We'll explain that in the EnCase section. And AFF. Now, here's the thing with proprietary and AFF as opposed to raw. We've got a lot of metadata that wraps around the outside of that file. We don't want to inject it into the file because the file must remain consistent and admissible, so we try not to change it, or don't change it, please. But we may want to do some metadata around that. Like if we're doing disk duplication and using the AFF format, does the tool that's pulling down the information hash it for us, and can we put that hash as a wrapper on the outside as metadata? I think that's a very reasonable thing as metadata goes to have available to you that is output from the tool that's actually doing your disk duplication. So there is metadata wrapped around the outside of this particular image that we're creating. Now, when we're acquiring the image from somebody else, we have to ask ourselves two questions. How much data are we duplicating? How much time do we have? And that's a balancing act that goes back and forth. When it comes to size of source disk, today any end user can go out and buy a 2 or 3 terabyte drive. We need to be prepared for that. In today, when we walk into a server room with a storage area network, we could encounter hundreds of terabytes. What's the mission of our forensics lab and our forensics business? And we'll have to match our resources to that, including the disk duplication capability. So we're going to have to match all of those things together. So that's disk size. Well, what about time? Well, if we decide to do imaging of, say, 3 terabytes of data, that process may take too much time according to the conditions that we're given. When we're dealing with warrants to seize, search and seize equipment, those warrants may need to be posted early. The opposing counsel, you'd like to have the sneak in and grab it so that nobody can mess with it. But you may have opposing counsel find out about your warrant, and they'll go get an injunction against your warrant to stop you from seizing that data. So now it becomes a race. When your ticket lands on the desk, they have to start allowing you to do it. When the other ticket or the cease and desist order comes in, you have to stop. That might be a matter of 2 or 3 hours or 30 minutes. So we can't work quicker than, say, an eSATA drive will actually allow us to capture the information. And probably if it's a single workstation, pulling that data off of that workstation, it's probably not going to have the super fastest drives on it. It's probably going to have some old lame 5400 RPM drive that it's going to take a long time to pull that data off. You also have to ask yourself, can you retain the source disk as evidence, or do you have to return it to the owner at that moment in time? When we're talking about disk imaging and we're talking about storage area networks, you usually don't do the disk image. What you tend to do is you tend to do what we call file copy, because we don't have the space, we don't have the time, and we can't address the RAID array in most cases as a total contiguous unit. But there are some tools, and we'll talk about those tools, that can do this for us. So you got to be quick about this. You got to get it done, and you got to know how long it takes, and you need to know your speeds and feeds of your data pipes when you're passing that over. You need to know how fast this system is, how fast that drive is, and make sure that your system is not the bottleneck on this. And we talked about that in the hardware section. So if your time's limited, sometimes you're going to have to choose a logical acquisition or what's called sparse acquisition. So what's logical? Well, that's particular files of interest to the case. We're looking for files that say the word fraud in them. If you go back to the Windows section, let me ask you a question. What files would you go after that are on the live system? Which ones would you capture first? If you said the recycle bin, if you said the index.dat, if you said any one of those files that we talked about in the Windows Forensics section, you'd be right. But you need to know the specific files that you're going after. Now, if this was not an internet crime and this was only local to the machine, you might only search for Excel files or Word files or QuickBooks files. Knowing what kind of software is on the machine will also give you some direction as to what data that you can capture quickly that becomes a part of the evidence that you're going to present in a court of law. So sometimes it might just be the docs and the standard office files that you're going to acquire because it's all you have time for. So you pick specific files that will give you specific information. Oh, by the way, if you've put down your search and seizure warrant and you know that that next cease and desist order is coming in and they say, hey, you've got 30 minutes, what you can do is you can capture the information that you need at that moment in time that will give you an extension on your warrant to get more information. So then we play the chess game of I'm going back to my judge and saying this search cease and desist order is inappropriate in this case because we've got 6 files here and we know that there are 6,000 more, but we don't have time to get them and they've told us to stop. Don't think that that particular person that's there that does a cease and desist won't try to wipe out this information. So what you want to do is you want to catalog what information is there so that when you go back to your judge and say, hey, I need you to renew that warrant and quash that cease and desist so that I can actually get this stuff done, Okay, so how are we going to do that? Well, what we do is we do a directory listing, and that output then becomes the list of files that we're looking for, but we capture these files to give us proof to go back and get the other files. So it's this, it's this back and forth chess game at a certain point in time. So logical acquisition says, logically, I need these files right now to maintain this piece of evidence. Sparse acquisition says we're going to collect fragments and unallocated and deleted data, and that gets into areas of the disk that don't have a lot of stuff on them. Sparse means that there are very few things there. Acquisition methods: bitstream copies, disk to image, disk to disk, and sparse data copies. We're going to look at each one of those. Disk to disk, bitstream. This is usually what we think of as an image file. And we're going to go from an original disk to another disk. Remember, the target disk has to be at least as big as the source disk unless you are using compression tools like Encase's tool. Disk to disk, they need to be exactly the same size. They don't necessarily need to be the same geometry, or they need to be, your disk, reference disk needs to be larger at that point. Sparse data copy. Just pick up the only part of the large data set where you're looking. Where's that deleted area? Where is that partition that is marked deleted by the operating system but exists physically on the disk? Why is it deleted? Maybe we want to go in and grab that particular portion of the disk drive. The idea here is we don't have a lot of time, so we need to reduce the overall size of the data that we are acquiring so that the time actually gets shrunk down. And that's the first part of what we're talking about in data acquisition.